I don't want to know. I don't even. It's gone.
I'm going to rephrase my question.
Yeah, I just wasn't sure.
How would you make that? Okay, so what'd you come up with? Don't tell me nothing. What compounds you can use to make that?
Primary, secondary.
Yeah, what are we making? There's only one answer for this one. Remember that last one we did? There were two different answers. This one only has one. Okay, so where do you want to start? Where did you break the molecule? Remember what the carbon that the OH is attached to. What does that tell you? What is this? Carbon. What does that have to be? The carbon of the what? Carbonyl. So what is my carbonyl compound going to have to be? What is the carbonyl compound going to have to be? Is it going to be an aldehyde? What kind of alcohol is that? Come on, I sang the song for you and everything. No. You want to hear it again? You can watch the video. I'm already worried. Okay, so what kind of compound do we need? Are we going to use an aldehyde? A ketone. Okay, which ketone? Okay, if you're going to split that in half, where are you going to cut the molecule? Can I cut it up here?
No.
Here? Why not? Because of the ring, right? So what is the carbonyl compound got to be? Has to be what?
A propyl with the carbonyl on it.
No.
Oh, wait, and I mean, or with the, yeah.
You guys got to get good at these. They're going to be everywhere. Okay, what does this piece become?
Is that where the part attached to the
So this would go here, out to the O.
So
remember, follow through. What?
So it's that hinting ring, the same thing as that. Are those the same ring?
Basically, I drew one in purple and one in
I just didn't know if you
green.
just added another one.
No. Okay, so if you were going to write the whole thing out, you don't start with the Grignard. You start with what? Okay, an alkyl halide. And then what do you add? Magnesium. And that gives you that. Then what do you add? The carbonyl compound. And what does that give you? That gives you that, right? And then what's the last step? Add acid. So what should I write on my arrow? Okay, it might be sulfuric acid. There's going to be some homework, where you're going to practice finding the reagents, okay? And you slide them onto the arrows where they go, kind of thing. Okay. All right, so what's the structure of the organic product from this set of reactions?
I feel that.
Mm-hmm.
We're just talking about how well it's safe.
Sorry. I'm not giving you your test back. Does that make you feel better?
Yes. I don't want it back.
Just
Keep it forever.
Just keep it forever. Don't put them in blackboard. So I should just drop everybody's first test.
I think that would be a wise.
Oh, that'll make me cry. Yeah. We got 3 more tests to go. I got 7. I don't think they ever cleaned it before. All right, make a guess. If nothing else, make a guess. Because an answer is better than no answer. Where are you going?
You got a clicker.
Side. Make sure you get the right one. Don't pick the wrong clicker. Someone else will get your perfect attendance. All right, did you make a guess? Okay, okay. All right, so here is my nucleophile, right here, this carbon, right? And where are we going? Carbon of the carbonyl, and then we go out to the O. I'm hoping that by doing it 50 times, you will do it right. When I ask you to draw out a mechanism on the test, you would think so. All right, then what does the acid do? It protonates the O- that you formed. Okay, so which one is it? A. Okay, how many carbons are in there? 1, 2, 3. 1, 2, 3. Okay, this is the new bond right there between those 2 carbons. Okay. Any questions? Are we starting to got it? Okay, we already did that one. I had it on 2 slides. Okay, so we're going to react our Grignard with esters, carbon dioxide, and acid chlorides today. Okay, we're going to do these 2 first because they're very similar, and then we'll do the CO2. Okay, do y'all know? Well, I'll ask you that when we get there. Okay, so let me just put in it's not, maybe I have to slide. Okay, I don't know. Let me scooch that over. All right, so here is, should I use our same Grignard that we used before? That we made and we used in all the other examples? All right, there's our phenylmagnesium bromide. Okay, how do you make it? We'll just review. How would you make that? What are we going to start with? Br on that benzene ring. Okay, and what do we add? Magnesium. Okay, and it's in a dry ether solvent. Usually it's ET2O, but THF can be used if you need it for solubility reasons. Okay, so I'm going to add it to an ester. Okay, I'm just going to pick a simple ester because that will be easier for you all to write. Okay, now when we do this, we're going to be very similar to what we did with aldehydes and ketones, because you'll notice that an ester has what in it? A carbonyl. Okay, so where's my nucleophilic carbon? It's the one attached to the magnesium. Okay, and where do I go? And then I go out to the O. See the pattern. Feel the pattern. Okay. All right, so what do I have at this point? All right, I have that attached to the carbon. That was the carbonyl. So what's attached to that carbon? What's attached to that? What do we got? We got a what? A methyl and what is that O? Negative and MgBr plus. Okay, and what else is on that C? OCH3. Let me put some lone pairs on there. Okay, now this is different than what we had before because we have a leading group attached to the carbon that had the carbonyl. So what will happen is our electrons on the O minus are coming back at you. They're going to do this. And guess what's going to happen? This bond is going to break. And that group is going to leave. You can't do that with a regular carbon. You can't do that with a hydrogen. Okay? You have to have something like a heteroatom. So what's a heteroatom? An atom other than carbon or hydrogen. So you have to have an O, a halogen, I guess a sulfur, but we're going to worry about O's and halogens. Okay, so now where am I? What do we get? All right, so we have this, and it's attached to what? A C. What's on that C? A what? A methyl and a double bond O. That O is now neutral, right? Okay, what happened down here? What do we get? O, CH3, and what's on that O? Minus, okay? What else we got in there? MgBr plus, that's your counter ion for the OCH3 minus, which will all get washed away in the end. Okay, now what kind of compound did we just make? What is that? What's the functional group? Ketone. What do you know about ketones? Wow. And Grignard reagents. Don't they react? So what's going to happen is a second one of these is going to react with this. And you can't say, stop, stop, don't do that. Because it's going to react with it's there. So you're going to end up using two equivalents of Grignard reagents. Okay? So if you were to say, I'm just going to put in one and try to trick it, what will happen is you will get mixtures of things that didn't react, things that reacted 2 times, and things that reacted 1 time and be a mess. Okay, so that's why you just have to go with the flow and use 2 equivalents. All right, so what do we have now? Notice that we went to the carbon of the carbonyl. We went out to the O, just like we did before. Okay, so we're going to have, here's our new benzene ring. I will make it red. Okay, there's our C. Okay, that C has the old benzene ring on it, right? Okay, what else is on there? The methyl and the O, and what does the O got? 3 lone pairs and a what charge? Negative. What's the counter ion? Same one it was before, MgBr plus. Now this time, can the O minus come back in and kick out these things? No, because they're all carbon-carbon bonds. Okay. All right, so now we're going to take this and we're going to add acid. Okay, so we're going to make what kind of alcohol? Tertiary. My poor little benzene ring was looking kind of sad there. I blame the pen. Okay, so look what we did. We made a tertiary alcohol, but notice that two of the R groups on that tertiary alcohol came from the Grignard. Okay, so if I said that we were going to use that compound, look how I'm going to do it. I'm going to write 1 mg, 2 3. And when you do this, you have to do it in those steps. If you throw it all in there at once, you get any reaction. Then you have to clean it up. Okay, so what do you get after the first step? Mg goes between the bromine and the carbon that it's attached to. So it will look like this. Don't worry about the mechanism to that step. It's inorganic. Organic chemists, most of the time, we're just happy. Have you seen the periodic table for organic chemists? Haven't I showed you that? Yeah. And in there it says we use these to do real chemistry. Some of the elements, yeah, they're pretty cute. And carbon is big and bold. And hydrogen is carbon's buddy. All right, now that's what we get after step 1. So what happens when we do step 2? What's going to happen? Where do we go? We're going to go to the what? And then we go? Are you getting better at that? Like almost automatic, right? Okay, because every time we do any reaction with a carbonyl, you go out to the. Okay, all right, so can you draw me what you have at this point? Okay, here's your clue. There's your clue. Okay, so what is this little carbon I'm going to mark with the red arrow? Okay, what is that attached to now? It's not attached to the bromine anymore, or the magnesium anymore. It already wasn't attached to the bromine. What is it attached to? The carbon of the carbonyl. So we're going to have a bond from here to here. Okay, that's our new bond. All right, now what do we got on that carbon? What are all my pieces? What do I have from over here? A CH3. What do I have from up here with all the red arrows? Yeah, I have an O minus. Okay, what do I have over here? The OCH3. Okay, now what happens? The minus does what? It kicks off the OCH3 minus. Okay, so what do you have now? 1, 2, 3, 4, 5, 6. Okay, you made a ketone, right? And you also got your OCH3 minus, and you have your MgBr plus. I'm not too worried about the MgBr plus, but I think your sapling likes it. So I'm making you write it so that you remember it. Okay, now what happens? Are we done? We ain't done. Ain't done yet. Okay, so a second one of these goes where? To the carbon of the carbonyl on the ketone. My carbonyl's kind of sad. Okay, so now what do I have? 1, 2, 3, 4. Okay, now what did I add? I added another one of these, right? So this is my new bond. I'll just make the whole thing. 1, 2. And we're going to get O minus MgBr plus. And then what are we going to do? Protonate it with acid. I haven't drawn a protonation step, so I'll draw it. Okay, that's hydronium ion. Can you tell? It looks kind of scary. All right, so it doesn't matter which H you pick. Want to go left to right or right to left, or bottom to top, I don't care. Just pick one. They're all equivalent. Okay, and so what is my product now? I've got 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, what carbon gets the OH and the methyl? 1, 2, 3, 4, 5. Carbon 5 in the middle. 1, 2, 3, 4, 5. So here's the methyl and the OH. Look at that. It's kind of complicated looking. Okay, and we started with 2 very simple compounds. Okay, so when you do this with an acid chloride, oh, we're going to a new page. Okay, so we're going to do this with an acid chloride. So we're going to use, I'm going to use a different. We're going to get off the methyl. Let's go to ethyl. Okay, and what do you want to use for Grignard? Do you like the benzene? Is that okay? I kind of think it makes it stand out. All right, so we're going to add the benzene. 1. I don't know why I drew that arrow like that. But it's Monday. Okay, so where are we going? I should have asked you where we started, shouldn't I? I didn't. Okay, we're going to go to the here, and then we do what? Out to the O. Follow through. Follow through. Okay. I don't know. Does anybody yell that in those little sporting events? Okay. I think I hit this with my arm. Okay. All right. There's your clue. I think I could have just written chlorine down. That's a better clue. All right, so where do I make a new bond between a carbon on the benzene ring, the one that was attached to the magnesium, and what? The carbon of that carbonyl. Okay, what is attached to that carbonyl, or that carbon, I should say? A what? A single bonded O with a negative. And there's your counter ion. Okay, what else? An ethyl. And what else? A chlorine. Okay, so what do you think happens next? The chlorine is going to leave. How does it leave? How do we draw the arrows to show it? Right. And that. Those electrons go there. So that chlorine ends up positive. No, it ends up negative. But I wanted to say, are you positive? Okay. No, it's negative. Okay. So can you draw what you have at this point? We're going to have no, but it does have a counter ion. Okay. Now what happens? We'll go to red. What? It does it again because we made a ketone. Okay, and ketones react with Grignard reagents. Even if you tell them not to, they don't listen. They're kind of like students doing their homework. They don't listen. All right, so what do you get? Well, here's one benzene ring. That was already there. There's my 2 carbons. Okay, so now I have a second benzene ring. I mean, this is looking fairly complicated. Okay, and it's a simple reaction you can do in an afternoon. Amazing. Okay, so what do I have up here? Sigh, crowdness is what I have. A crowded board. All right, and then what do I have to do? What's the last step, you think? Acid. It's always going to be there. Okay, so we're going to make a tertiary alcohol with 2 benzene rings on it and an ethyl group. Okay. Doesn't matter if you use the acid chloride or the ester. No, you can get the same thing. Okay, you can get the same thing. Which one would you use? Well, it depends what you got. Sometimes that's what it comes down to. If you had a lovely ester, esters are typically more stable. They hold up longer over time. So if you have an acid halide that has been there for a long time, it's typically not going to be real pure, and you're going to have carboxylic acid mixed in it, and that will mess everything up. Okay, so typically we don't like that. So I haven't ever done it with an acid halide. I have done it with an ester numerous times. Okay, so now, what do you get from this one? And then we'll do the carbon dioxide. If you finish this one, you can work out the Lewis structure for carbon dioxide. Now you got to do the name too, not just the structure. So you'll have to write it out and then name it. Okay, so you should come up with the structure and then figure out its name and then pick the right one. That's my advice. still on. Okay. All right, make a pick. We have more exciting things to do. I don't know where those things come. Okay. Wow, I got every answer. Oh my gosh. Well, except Luke. Nobody liked Luke? I figured 1 out of 25 was better than 0. Or 25% chance was better than 0. Okay, so what does the first Grignard go? Where does it go? And then you go out to the L. Okay, so where are we now? Okay, then what happens? And you form a ketone. Okay, that's electrons in that bond. All right, so now it looks on your papers. I'm just saying, I've seen it. Okay, so notice that we made a ketone. So now what happens? Goes to the purple pens have a tendency to do that. All right, so what are we going to get? 1, 2, 3, 2 methyls on that carbon, an O minus, and then what does the acid do? You like how I did that? Okay, so what's the name of that? 2-methyl 2-butanol, which is which one? B. Right? Alcohol gets lowest number, all that good stuff. Okay? All right. These 2 pieces right here, this methyl and this methyl, came from the Grignard. Okay? You gotta be able to do that. Okay, oh, I didn't do the CO2H. Okay, so let's insert a blank page. So now let's take our phenyl magnesium bromide. And we're going to add carbon dioxide. So did anybody figure out the Lewis structure of carbon dioxide? What is it? What do you think? We got to give our carbon how many bonds? 4. Each oxygen gets 2. That look familiar? Surely we saw that somewhere in life. Probably in general chemistry, but you might have seen it in like physiology. Did they not talk about how you exhale carbon dioxide and inhale oxygen? I would think that'd be kind of basic, but versus acidic. All right, so where are we going? It's all about that. All right, that's the only carbon we got, right? So now what do we got to do? We got to go out to the O, just like we did before. Which O do you want, the top or the bottom?
Does it matter?
No. It doesn't matter, but it matters that you do it. All right, so you want me to go up or you want me to go down? Okay. Whatever makes you happy. Whatever floats your boat. All right, so now what did I make? What do I have? Okay, there's that. I made a bond from my carbon on my benzene ring to the carbon on the CO2, right? So what do I have up here? O negative, and here I have, okay. Can that O negative come back and kick something out like we did in the last two examples? No, there's nothing to kick out. Okay, it's not going to just kick out an O. Okay, see that? See the difference between that one and the last two examples. Okay, so all we're going to do now is add acid. And what are we going to make? What kind of compound is this? Is it a secondary alcohol? Is it an alcohol? It's a carboxylic acid. We made an acid. Okay? When you add the acid, you actually have to check the pH and make sure you get all the way to 2 to make sure you got it all perfect. Okay? And then you would collect that in your ether layer or whatever in your cell phone, which I hope you're used to using now, right? Okay, good. All right. So if I say, okay, what is the major product? Okay, what's the major product gonna be? So what are you going to draw? You just have to draw the structure. You don't have to name it. Just draw me a structure. So how many carbons should I put in my little chain? Like that? Okay, what else you need? That methyl, that's on carbon 2, not worrying about nomenclature. It's on that carbon, okay. And then we need an OH. Okay. This piece is the piece that comes from here. Okay, so 1, 2, 3, 4. 1, 2, 3, 4. That's this piece. Okay. So what do I need on this carbon here? Okay. Notice that you increased by 1 carbon. Okay. Not 2, not 500, not 36, just 1. Okay. Just add 1. All right. You got them now? Okay. Alkyl lithium reagents, do you remember what they were? It's been a while. Like there was a test in there and everything. What are alkyl lithiums? There are attached to an lithium, an Li. Okay. And what do you know about the CLI bond? It's okay, where the C is negative and the Li is plus. Okay, it's either ionic or like almost ionic. It's probably, if you actually do the calculations, I don't know. You can probably do the calculations multiple ways. Wait, more about that. All right, but let's add an aldehyde. So I'll just make you one. How about benzaldehyde? If you've never heard of benzaldehyde, it smells like almond. It's actually found in almonds. All right, so what do you think we're going to do? Well, what did we do the last time we had a C- and a carbonyl? What did we do? We attached the C's. We went from here to the carbon of the carbonyl, and then we went That does not change. Okay? So what do we make? What do we get? Here's our benzene ring. There's your clue. Right there. Okay? That's attached to that carbon and that carbonyl. Okay? What is attached to that carbon now? On negative or on O negative, right? Yeah, O negative. O negative. Okay, is that your blood type? All right, then what else? And a hydrogen. Okay, what's the counter ion for the O negative? What do you think? Is it NGBr? No. What do you think it is? It's just the lithium. Be logical. Okay, then guess what we do? We have another step, and guess what we're going to add? So we're going to get, here we go. There we go. Okay, so what do we make? An alcohol. Guess what you get when you react with a ketone? An alcohol. Okay, what kind do we get on this one? Secondary. Guess what we're going to get on a ketone? Tertiary. It's the same. Okay. Sometimes it won't matter which one you use. Okay. Typically with the ones like the CO2, the esters, and the acid chlorides, you use the Grignard reagents. We don't use the alkyl lithiums for those because there are some other side reactions because the alkyl lithiums are a stronger base than the Grignard. And so there's side reactions you can get, and so you wouldn't want. So you would use the alkyl. You would use the Grignard reagent to put your oven. Okay? Okay? You got them? Always go out to the O. Out to the O. Okay. Now, there are some limitations of organometallics. Number one, they are strong bases, especially the alkyl lithiums. So they will react with, number one, any acid present in the reaction. In fact, when you finish, okay, you do step one, you do step two, you add your carbonyl compound, then you do step three and you add the acid, it'll fizz and react with any excess Grignard reagent that's in there. Okay, so if you had some extra, it's gone. Okay, which is good because then that kind of cleans it up for you. Okay, but anything that has any kind of an acidic hydrogen on it, even if it's a weakly acidic hydrogen, cannot be present in your mouth. So you can't have an OH, an NH2, an SH, an acetylenic hydrogen, or a carboxylic acid. None of those can be in your mouth. Okay? And all reagents must be dry, 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 dry. Okay? If they're not dry, 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 then the water will protonate your Grignard and the whole thing will quit. Okay? So it must be dry. And we know this from experience, let alone because somebody told me. Okay? All right? Okay, now there's a thing called the Gilman reagents. They also have copper in them. So look at this. We're getting into the periodic table here. Okay, copper, remember, is Cu, right? Not CO. What's CO? Cobalt. All right, just checking on y'all. Okay, so in order to make them, you take an organolithium and you add copper iodide to it, and it's 2 to 1. And you'll notice that you make this R2CuI. That is the Gilman reagent. The Gilman reagents were developed by Gilman, yeah, like it made sense. I thought, jump on that one. Okay, they react with alkyl halides. Notice the exception. Those fluorides, they just mess up. Okay, and you form alkanes. And here's your favorite statement. The actual mechanism is unknown and is thought to involve free radicals. That means you don't have to know it. Right? Right? Okay. All right. A lot of times this is done in THF. Who remembers what THF is? It's a ring. How big is a ring? 5. And what does it have in it? Okay. That's it. That's key. In case you forgot. Yeah, I told you about making it blue. No. All right, so what happens is you take an alkyl halide and you add that copper lithium, okay? Notice it's 3 carbons 2 times. So this will actually allow you to use 2-to-1 ratio, okay? But only 1 gets put on the alkyl. And so we had 4 carbons here, and we're adding 3 carbons here, and guess how many we get? How many carbons is heptane? 7. What's 6? Hexane. Checking. All right, now look at this one. This one has the alkyl halide is attached to a double bond, and it works with that. That's kind of exciting because you can make some really complicated things, again, really quickly. Okay? And it's just that one little step. You don't have to do the acid and all that. Now, you do have to make this thing. Okay? You do have to make the Gilman reaction. I don't think you can buy them. I think you have to make it. Okay? Here's the other thing. You can have carbonyls present. It does not react with carbonyls. So look what you can do. You can have this compound here. It's a ketone with a bromine on it. We're going to add a dimethyl copper lithium, that Gilman reagent, and look what we did in one step. Cannot do that with alkyl lithiums or Grignard. Okay, if you tried to make a Grignard of this, okay, you've got a carbonyl in there, it's going to start, oh my gosh, it doesn't work very well. Okay, so that's kind of the exciting part, is that you can do some things with these copper reagents that you can't do with the lithium or the MgBr or whatever, the magnesium of the Grignard. Okay, the copper just kind of like modifies the negative charge on the carbon cell. That's the only thing that I. Okay, so now I want you to tell me the best reagent to do that. Yeah, we still have reductions to do. I think that's pretty much the last. So I'll make sure your slides get posted later today, so you remember if you might start the next bit. How we doing? Got 11:50. Do we have 17? Yeah. All right. Yep, it's C. Somebody called on the force. Did it help you? Look, it's even purple. There. Get there. Look, I even used the same compound. I tried really hard to make it easy. You don't like to take those points, though. Oh, this is what I do wrong every day. There we go. All right, I'll see you all. I don't know. I'm guessing on Wednesday.